All right. So, for our next guest for Data Structure Storytime, we have Dr. Mark Cartwright. He is a software engineer at Google. I met him when I was again at the um, Google Faculty in Residence program, and we bonded because we have, went to the same university, and so we just had a really good time reminiscing about. You'll all know once you all graduate from UIC and meet up with someone from UIC. So he has really been in the field for quite a while, and so he has a lot of knowledge. And so moving from some of the student stories now into some stories with people who have been doing this work for a really long time is super interesting to see kind of both sides of it. And I told him to talk about a lot of times when people are working in industry, particularly at like Google and Amazon and whatnot, they can't talk a lot of details about what they're doing. Um, but I asked him to tell us about kind of one of his favorite data structures. And we also chatted a lot about abstractions and data structures and what's the difference and how to place different things in those categories, which is like not as straightforward as you would think it is. But anyway, he tells you a story about just a really unique one that I think you'll really enjoy. And obviously, immediately after he talked about it, I went and looked at my own knowledge panel on Google because I'd noticed that they started having knowledge panels. I don't know, I think it's like over the past year. And so when he said it, I was like, oh. And so I went and looked at it, which was fun. You'll understand what I'm talking about after you watch it. All right. Enjoy.
Okay, so Mark, we're going to start with an introduction. So do you want to introduce yourself to all the students?
Sure. Hi, my name is Mark Cartwright. I'm a software engineer at Google, and I have a PhD in computer science with a focus on what's known as information retrieval, which is search and search engines and search engine technology. So Google is a pretty fitting place. I met Shannon at a faculty in residence summer 2019, where she came and visited Google for a month and took a crash course in like all things Google, and hopefully learned a few things from some of the engineers there on what are the kinds of problems that we'll deal with at a company like that, so that she can better prepare her students for those kinds of problems.
Yeah, definitely. And it's really influenced a lot my data structures class for sure. So one of the things that we're doing here, because this is for the last week of the semester, and everyone is like very tired, and so we're doing story time. And so we're asking just to hear a story about your favorite data structure.
Okay. Well, at this point, I can assume that your students have been inundated with tons and tons of data structures and abstractions and other things. And over time, I think I've just come to really enjoy the graph as an abstraction. And I mean, in some cases, also as an implementation. You can implement a graph in many ways. And so it makes it interesting because depending on how you want to use the graph really helps dictate how you want to implement it. You could do it as an adjacency list. You could do it as a set of triples. You could just do it with like nodes and pointers if you really wanted to. And so there's a lot of interesting engineering questions, but also just from sort of a representational perspective. You can just draw it on paper, but it lets you express a lot of different complex relationships very cleanly. I mean, not necessarily like compactly, but in a way that everyone almost immediately understands, right? So you have problems like the internet, right? So all of the web pages sitting on the internet and all sites with all the links that are connecting them. Whenever you add a link to another page somewhere, you're basically adding an edge in that graph. So you can just think of like this huge graph of the World Wide Web and how things are connected. And that's a pretty common representation now for search engine companies. But you can also think of other things like the social network. Obviously, that powers Facebook is basically also a large graph, right? You and the friends that you connect to and the friends that they connect to and everything form a really large graph. And, you can infer a lot of things by knowing, if one person is a friend with another and that person is, into dogs, then maybe their friend is into dogs and things like that. And you can just kind of keep going with that. You can represent, cities and roads and houses and towns as a really large graph. I mean, the traveling salesman problem, assuming you've heard of it by now, or if not, you can always look it up. It's basically a large graph problem. And, to some degree is, I wouldn't say solved by Google Maps, but certainly that's a pretty good crack at it, right? Well, trying to get you from point A to point B and maybe to point C is basically taking you along a really large, complicated graph. You can, I've seen things like protein folding structures represented in a graph format. I've seen the energy grid represented as a graph, right, where you have the power producing places that then send energy down to a larger network that will connect all the houses. So you kind of have sources and sinks in that kind of case. So it was very clear that you have a directed kind of network or graph in that case. You also have what Google calls the knowledge graph, right? So that powers like the little panels at the bottom of the page. If you ask for like a person or a place and we know enough about it, we'll show you that panel. And the knowledge graph is basically trying to connect everything to everything else. That's a concept in our society, right? So you have basically any idea that we've ever thought of, or any person that's notable enough to have lived, probably in Wikipedia, or any place. All those things are connected, and you have all these different relationships that can be represented by the edges in that graph, right? And so you could have a parent-child relationship. You could have something like type of relationship. So you could have something like an apple is a type of fruit. And then fruit might be like a type of food or type of plant. You could have, timing. So you could even have relationships where you could say, oh, the World Cup was held in, Brazil this year. And then like there's another World Cup that was held in Spain another year, and the US another year, and so on and so forth. So you can even connect these things, based on concepts of time, right? So there's no reason why the year 2020 couldn't be a node in that graph, although it might be a node that none of us want to keep. That's a different issue. It's been a rough year,
Yeah.
So yeah, the graph concept to me is really powerful and really useful, because it's easy to represent the objects you wanted it and then the relationships between them, and you can even optimize it to sort of operate the fastest way you want by the way you implement it.
So these knowledge panels they're fairly new, right?
Oh, they've been around. I think at this point they're 2012 or something.
Oh, really?
I mean, there's been there was a company called I want to say it was Freebase, but I'm not sure it was that. But there was a company that started the knowledge graph that Google acquired, and that was sort of the beginning of it. And then we've just been sort of accumulating more facts and more connections over time. And it's used, to make a lot of inferences based on those connections. But it's also an interesting problem because it isn't just building this graph and sort of adding new facts, but you also have to evolve it in case things change, right? So you can imagine if you had two people who were married and then they got a divorce, you have to change, the relationship, whether it's remove the edge between them or you change that edge to say, now divorced or whatever. If you want to represent sort of the state of the world as it is right now, you have to make sure that you're also updating the facts that you have in there to have the right relationships, right? So like the nodes may not go away, but you might want to make sure that the connections between them change and are up to date. So it's this really interesting, like large sort of surgery kind of process, right? Where like the graph is kind of alive, right? You're adding facts all the time. You're updating facts. You might be removing facts that are no longer true or have been updated. You can imagine that a bunch of facts got added from COVID, and the information was coming in really fast on that kind of thing. And so you can imagine that facts like that might have been getting revised over time, depending on what's been coming out and what's been getting updated and so on and so forth.
Yeah, that's super interesting to think about. Yeah. That's a great example and a great story to have us thinking about graphs. So yeah, I think that's it. I'm gonna stop the recording now. Do you have any last words for our data structures class?
Um, yeah, I mean, these things end up being more powerful than you think.
Mm-hmm.
And always think about the best way to represent your data, right? Maybe just start by drawing it down and then thinking about how you would want to deal with it. And that's probably the way you're going to want to write your code around it, right?
Mm-hmm.
Don't try to shoehorn into a particular data structure because you think that's what everyone's using. Use the one that feels that's going to make it easier for you to think about it. Because the less mental overhead you have in dealing with those things, the easier it'll be for you to write code or make use of the data you have effectively.
Yeah, it's great advice. Okay, thanks, Mark.
Thank you.
Okay, a quick note. One of the reasons I was asking him if knowledge panels were new is because I recently noticed that mine showed up. And what was interesting is he explained that the reason for that is because they keep adding more data to it. So basically, they're just like making more and more connections across the internet. So they're probably just getting more and more people into the system. And so it just showed up because, it's advanced enough to include, someone like me who just has like a Google Scholar page, or something like that. So I thought that was kind of interesting because I actually just recently noticed it over the past year that I had one. So I just thought in all UIC faculty have one. So okay, I mean almost all. So yeah, hope you guys enjoyed that. See ya.